Problem 4. Let S be a subset of the set of numbers 1, 2, 3, and so on up to 2008, which consists of 756 distinct numbers. Show that there are two distinct elements, A, B, of S, such that A plus B is divisible by 8.
We'll solve this problem using the pigeonhole principle. In its simplest form, this says that if we have more pigeons than holes, then we must be able to find a hole that has at least 2 pigeons in it. In fact, it says that if we have kn plus 1 pigeons and n holes, then there must be at least one hole that has at least k plus 1 pigeons in it. And here I have 3 pigeonholes, and I have 7 pigeons, and you can see that if I put all these pigeons in the holes, we must end up with one hole that has at least 3 pigeons in it. In this problem, we're asked to consider S, a subset of the set that contains all the integers from 1 up to 2008. I'm going to start by partitioning this set into 5 subsets. In the first subset, I'm going to put all the numbers that are divisible by 8, exactly. I'm going to write 0 here to signify that when we divide them by 8, they leave a remainder of 0. In the next set, I'm going to put all the numbers that leave a remainder of 1 and 7. In the next set, I'll put all the numbers from this set here that when divided by 8, leave a remainder of 2 or 6. And here, 3 or 5. And finally, put all the numbers in this last set that leave a remainder of 4. And so we have partitioned this set. Every number from this set is now in exactly one of these sets. If our set S contains 2 numbers that fall inside this set, then those 2 numbers will add together to give a multiple of 8. They're both multiples of 8 themselves. And so we'll be done. Similarly, if S contains 2 numbers from this set, then those 2 numbers, which both leave a remainder of 4 when dividing by 8, will add together to give a multiple of 8 as well. And we will also be done. So we just have to consider now the case when this doesn't happen. So the case when we have at most one element of S in here and at most one element of S in here. And this means that in the middle 3 sets, there must be at least 754 elements of S. Now 754 is 3 times 251 plus 1. And here's where we can use the pigeonhole principle. This means that there must be a set, there must be at least one of these 3 sets, that contains at least 252 elements of S. And let's assume without loss of generality that it's this first set, the set of remainders 1 or 7, modulo 8. In this set here, when we partitioned the numbers 1 up to 2008, we end up with 251 that leave a remainder of 1 when dividing by 8. But we've just said that there are 252 elements that we've chosen for our set S, and that means at least one of them must leave a remainder of 7 when we divide by 8. We can argue exactly the same the other way round to show that at least one of them must leave a remainder of 1 when divided by 8. And then if we add these 2 together, we're adding something that leaves a remainder of 1 and something that leaves a remainder of 7, and we get that these 2 add together to give a multiple of 8. And we're done.